Alright, welcome everybody. So today I'm going to talk to you about some of the functional groups that you're going to see beyond what is in the alkenes and the alkynes. And so we're going to talk about those functional groups and how to name some of these compounds, and we're going to practice some of this tomorrow in class. So there are 14 functional groups that you're required to know, and I've listed them here for you. Here's a list of them circled from last time. Alkanes, alkenes, alkynes, the arenes, which are those aromatic compounds, alcohols, which have an OH hydroxyl group, ethers, aldehydes, ketones, carboxylic acids, esters, amines, amides, nitriles, and then the halides. Now, there are some that you need to know in more detail, which we'll get into, like alcohols, halides, and amines. You should know the difference between what a primary, so they have that here. When they say primary, they have a 1 for primary, secondary, and tertiary mean, and I'll show you what that means in the notes. You're going to be responsible for being able to know those general formula of alkenes, alkynes. I've told you that before. But on top of that, you need to know aldehydes, ketones, alcohols, carboxylic acids. I would know all of them. I mean, I would know all the ones that I'm going to put on the list, what the general, formula, what their alkyde, what their structure looks like. So this is straight from your textbook. I just took this, copied and pasted it from your textbook. And, this shows you the class of compound on the left here. It shows you the functional group. It shows you the name that it ends, and it gives you an example, and it gives you the general formula. So, if you're an alkane, we've gone through this one, you have CnH2n plus 2. If you're an alkene, that takes away some of those hydrogens because you're unsaturated, you have a double bond now, CnH2n. And alkynes, now you've taken away more hydrogen, so it's CnH2n minus 2. Rounding out the hydrocarbons includes the arenes, the phenyl group. So notice when they talk about the functional group, and this is something that we haven't really discussed, when you're an alkene, you have an alkenyl group. And when you're an alkyne, you have an alkenyl group there, as opposed to an alkenyl group in the alkenes. So notice the slight difference there. In all of my looks through these old tests, I haven't really seen a lot on those functional groups in particular. They ask mostly about the functional groups that are coming when you add oxygens, nitrogens to the compound or halides. Here's an arene, and they call this a phenyl group with a YL. The halogenal alkanes. Now these are what we call halides if you look back at the Regents reference table, but they call them halogenal alkanes. And this is just adding a halogen. Then there's alcohols, which have a hydroxyl group. Aldehydes, which have an aldehyde group. Ketones, which have what's known as a carbonyl group. And carboxylic acids that have a carboxyl group. So the carboxyl group has 2 oxygens, whereas the carbonyl group has 1 oxygen. If I look at this aldehyde and carbonyl group, these are isomer pairs of each other. So those isomer pairs of each other, they would have the same general formula really, except for where the oxygen is, and we can see that here. Here's the oxygen in the middle, and here's the oxygen at the end. The carboxylic acids have a COOH. Below the carboxylic acids are the esters, and these are isomer pairs as well. And you can see that they have the same 2 oxygens. It's just the placement within the molecule of where the oxygen is. Then we have ethers with the O in the middle. And these actually relate as an isomer to alcohols. We have amines that have the amino group. We have amides that have the amido group, and we have nitriles that have the cyano group, CN. These are the names of the endings to the different compounds, the suffixes that they contain, and then here's their general formula. Honestly, I haven't seen much on the general formula for a lot of these. I know them from the other table, but I would definitely know the name of the class and the name of the functional group. And then they give them, examples of each one. Now, something that's important here for the ethers, I name them where I put YL and then the word ether. And this is how I was taught to do it. They actually do an ethoxy for the part of the structure that is connected to the oxygen, and then ethene. And I'd have to look up how that would work if we had like a methyl and an ethyl, if the longer chain is the one that gets the oxy ending. But we can try that. I'll look that up and figure that out. Okay, so how do we actually go through and do this? How do we name these compounds? And you should have, like an idea of how to name each of these functional groups. And so what I'm going to do is I'm just going to insert a page here, and we'll do that here actually. And we'll go through how to name each one of these, at least a few of them. Let's add a page. So let's take something like, if we were to have a compound like this, if we were to have CH3, CH2, CO, CH3. So if I'm given a compound like this, I could use, if I know the chart really well, I could look and see if I find that on here. And if I look, I see that here, I have my C with my O, and then I have another R group, another group of carbons. And I can see that I have that here too. C, here's my R group 1, and here's my R group prime, and my 2 groups of carbons. Another way is I could actually just write this out. CH3, CH2, C double bonded O, CH3. Now it becomes clear that the functional group that I have here is a carbonyl group. Notice I don't say that it's a ketone. That's the class of the compound is a ketone. If I want to name this 1, 2, 3, 4 carbons, I have my 4 carbons is bute. And when I write out a ketone, the ending is anone. Notice also I don't include a number, because a number would show that it could be in another place. Remember, I said ketones and aldehydes are isomer pairs. So if I look at an isomer of this where I put the double bonded O at the end, it's still bute, but now it's butanol. Now when we look at how they name these, if we scroll up here, I'll go back down to that, but the aldehydes, they end in anal, and the ketones, they end in anone. Now they also talk about different types like secondary, primary, tertiary. And so you need to know this for halides, for alcohols, and for amines. And what they mean by primary is that you have a chain of carbons, and then at the end of it, you have your functional group. And we could put a Cl or an OH or a nitrogen with 2 H's there. And so when I think of primary, it's connected. That means that the OH or the halide or the amine, what that's telling me is that's telling me that the group or the functional group, it's connected to a carbon that has 2 hydrogens and 1 other carbon. So they call it primary because this carbon that it's attached to is attached to 1 other carbon and 2 hydrogens. If we have secondary we would have where the OH or the amine or whatever it is that we attach is attached to a carbon that is attached to 2 other carbons. 1, 2. And if we're tertiary, we would have that functional group attached to a carbon that is attached to 3 other carbons. So that's what they mean by primary, secondary, tertiary. Now, this is some basic stuff with the different types of functional groups. This is what they mean by primary, secondary, tertiary. Really what you have to do is sit down and memorize that chart and know it pretty well on how to name the compounds. In class, we'll practice how to do some esters and how to name some other compounds. We'll use the chart and we'll practice together so we can really go through it, but it's really your job now to sit down and know this chart for class tomorrow. All right, thanks for watching and have a great day.